Pluto, the mysterious dwarf planet that inhabits our solar system, is causing excitement in the astronomical community. Recent reports suggest a possible collision with Neptune, causing concern among scientists and space enthusiasts. Famous experts, Neil deGrasse Tyson and Michio Kaku, have warned of the consequences of this celestial collision. But why did Pluto end up on a collision course with its neighbor, and what does this celestial collision mean for us on Earth? Let's take a look at what is happening. Once considered a full planet, Pluto was later classified as a dwarf planet due to its unique orbit. Despite this change, astronomers continue to be fascinated and engaged. New predictions by prominent scientists show a surprising closeness between the orbits of Pluto and Neptune. These experts warn of a collision between two planets, which is a real threat to Earth. Pluto's journey around the Sun is marked by its unique features in the solar system. Its orbit takes 248 years, and since its discovery in 1930, Pluto has yet to complete a complete revolution. The highly circular shape of the orbit, a departure from the nearly circular orbits of the larger planets, adds to its charm. In addition, Pluto's orbit is tilted 17 degrees to the plane of the ecliptic. Because its orbit is wider than the other planets' one of the most notable features of Pluto's orbit is its crossing of Neptune's orbit. Taking about 20 years per orbit, Pluto moves closer to the Sun than Neptune, defying expectations about its position in the solar system. Why is there no collision between Pluto and Neptune? The explanation lies in the gravitational influence exerted by other planets. Studies of Pluto's orbit began shortly after its discovery, presenting a confusing path for astronomers. Unlike most planets that are close to the plane of the ecliptic, Pluto's characteristics are its steep orbit and elliptical shape. This mystery deepens when we realize that Pluto's orbit crosses Neptune's orbit. The persistence of Pluto's orbit through these disturbances serves as an indication of the complexity of space engines. The three-body problem in space involves understanding the motion and interaction between three celestial bodies, such as Pluto, Neptune, and the Sun. This problem explains the complex relationship between orbits and their energy barrier. Astronomers argue that azimuth storage is an important area, responsible for keeping the planets in their orbits, and plays an important role in the case of Pluto and Neptune. This fact indicates that Pluto will cross the orbit of Neptune, which is more than 90 degrees away from Neptune, making a collision impossible. Latitude libration ensures that when Pluto approaches Neptune or other giant planets, it is situated significantly above their orbital plane, providing an additional layer of protection against collisions. The VZK oscillation explains why Pluto's orbit around the Sun appears unusual but remains smooth over time. Despite apparent randomness in space, numerical simulations in the late 1980s revealed that despite stable properties, Pluto's orbit is technically chaotic, with minor initial deviations leading to significant differences over millions of years. However, Pluto's unique orbit maintains stability over incredibly long timescales, keeping chaos in check. Recent computer tests have enhanced our understanding of how large planets like Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. Neptune's unique conjunction with Pluto, which completes 3 orbits for every 2 Plutos, greatly contributes to the stability of Pluto's orbit. In addition, the influence of Jupiter's energy is great, but the influence of Saturn, although less, plays an important role. Through many experiments, scientists have shown that the conjunction of Neptune, Jupiter, and Saturn ensures the safe and stable movement of Pluto throughout space for billions of years. These conditions are necessary to maintain the stability and predictability of global climate movements. Without these conditions, the solar system would become more chaotic and unpredictable, possibly resulting in collisions or ejections from stable orbits and ripple effects on other celestial bodies. Understanding Pluto's orbit is important amid discussions of a future collision with Neptune. This knowledge will provide a clearer understanding of the dynamic nature of the solar system. The case of Pluto shows how unstable orbits can reach equilibrium through a complex interaction between gravitational forces and orbital mechanics. It is important to observe and continue to study these trends in order to better understand our place in the world. Space exploration often reveals the unexpected nature of celestial bodies, and Pluto's orbit is an example of this surprise. The theory of orbital chaos clearly shows the dependence of the orbit of a celestial body on its initial conditions. As shown with Pluto, Even small changes in the dwarf planet's position or speed can alter its orbit over a long period of time. Computer simulations are useful in helping scientists understand how Pluto moves through space. By making small adjustments to these simulations, astronomers can have a big impact on Pluto's orbit. In the late 1980s, these simulations revealed an interesting feature of Pluto's orbit. Although factors such as azimuth and latitude contribute to its stability, Pluto's orbit remains unpredictable. Even small variations in Pluto's position or speed can cause large changes in its orbit over many years. Despite this chaos, Pluto's orbit remains stable for a very long time, lasting for 1 billion years. This suggests that beneath the orbit, Pluto's journey around the Sun follows a structural sequence. Predicting planetary events is a real challenge, especially for planets like Pluto that have unpredictable orbits. The unpredictability of these systems makes long-term predictions uncertain. Numerical simulations help us understand and predict the future paths of celestial bodies, but they also reveal the limits of our predictive abilities. These models rely heavily on initial conditions and simulate complex interactions. Although small errors can lead to different results, accurate predictions are difficult. The absurdity of orbits like Pluto reminds us. Renowned astrophysicist Neil deGrasse Tyson has a unique perspective on the mysteries of our solar system, especially Pluto. Famous for redefining Pluto as a dwarf planet instead of a full planet, Tyson shares insights on how our understanding of celestial mechanics has changed over time. Tyson sees the classification of Pluto not as a reduction, but as a necessary correction for our growing knowledge of the various objects around the Sun. His approach to celestial mechanics is always learning and adapting. The complexity of orbits like Pluto reminds him of much more activity than can be seen in space. Tyson believes that the lure of these unknowns is what makes astronomy so exciting. Additionally, Tyson understands how space events and discoveries can increase the public's interest in astronomy. He believes that events such as the classification of Pluto and its unusual orbit will have a chance to capture the public's imagination and curiosity about the universe. By discussing the exciting and sometimes confusing aspects of space engineering, Tyson seeks to create clarity and understanding in the world. Neil deGrasse Tyson opened the door for the public to marvel at the wonders and mysteries of life. Working with other scientists, Tyson is seriously warning people about the dangers of Pluto's unpredictable orbit. After studying Pluto extensively, he raised concerns that the triple body was in trouble and suspected a collision with Neptune. In addition, Tyson emphasized how such an approach could disrupt the rest of the world and cause harm to the country. The collision between Pluto and Neptune in the solar system is unusual and dangerous. This collision would have produced so much energy that Pluto would be lost due to its small size and ice formation. Debris from the collision is scattered throughout the solar system, potentially hitting other planets and their moons. For Neptune, this encounter can change the atmosphere and direction, depending on the specifics of the event. Michio Kaku, a renowned theoretical physicist known for his work in string theory and general science, has a unique perspective on this phenomenon. His views on the future of space exploration and the relationship between celestial mechanics and theoretical physics are deeply reflected in phenomena such as the orbit of Pluto. Kaku sees the study of Pluto and its orbit as a vision for the future of space exploration. Understanding the complex gravitational interactions and orbital dynamics of celestial bodies like Pluto can provide valuable insight into future space missions, Kaku said. This knowledge can guide the solar system more efficiently, predict possible disasters, and plan missions to the outer regions of the solar system and beyond. Kaku emphasizes that the lessons learned from studying Pluto's orbit can be used to explore other celestial bodies and make plans for approaching and understanding distant worlds. When discussing planetary physics, Kaku often points out the deep connection between celestial mechanics and theoretical physics. He believes that planetary motions and interactions, such as the orbital dance between Pluto and Neptune, are not isolated, but related to fundamental principles of physics. Kaku's goal in theoretical physics, especially string theory, is to understand these principles at the first level. He says that by studying the complexities of celestial mechanics, such as Pluto's orbit, the fundamental laws of the universe can be understood. Like Tyson, Kaku focuses on possibilities and connects them to his theories about the world. When Pluto collides with Neptune, Keiko believes that the amount of energy released will have a big impact on the rest of the world, not just the entire world. According to his calculations, the release of this energy can disrupt the threads that hold the world together and create a level of destruction. Astronomers and space agencies continue to monitor Pluto's orbit in hopes of gaining new insights into a possible collision. While scientists like Tyson and Kaku may not be sure about the long-term consequences, they agree that a collision between Pluto and Neptune poses a serious threat to the solar system and beyond.